Thank you, Marco, and thanks to everyone for dialing in today. Obviously, a big thanks to WoodSolutions and Kylan for hosting and inviting us to present today. So my name is Jesse Hallen. As you saw, I'm joined by Marco Arcolini, and together we are the founders of TimberXP. And if you've ever wondered what the XP comes from, it is experience and expertise in structural timber engineering. So in terms of what we'll cover today, we'll start with a quick intro to our company. I'll then hand over to Marco, who is our principal engineer and bracing and connections guru. So he'll take us through some different mass timber bracing typologies. We'll look at connection details and some design considerations. We'll touch on structural analysis and specifically handling connection stiffness in a finite element model. And we'll close with some comments on holistic design, so considering aspects such as fire, manufacturing, and installation. So, TimberXP is a structural engineering consultancy founded early last year. Actually, our company has its origins in Lendlease Design Make, where Marco and I started working together 6 or 7 years ago now. So if you haven't heard of Design Make, as the name suggests, it's a business, or it was a business unit in Lendlease, which was dedicated to the design and manufacture of mass timber buildings. So Design Make delivered a good portion of Australia's mass timber buildings. So projects such as Forte and Library at the Dock in Melbourne, International and Darramoo Houses at Barangaroo, 25 King Street in Brisbane, and the Marie Ray Teaching Centre and Fenner Hall student accommodation at the ANU. So after the closure of Design Make, Marco and I continued on for a few years in Lendlease Digital, but we eventually decided to get back to our Design Make roots, and TimberXP was born. So we have a strong focus on mass timber, light timber framing, and hybrid systems. We're happy to get involved in projects large and small, so anything from concept or scheme design through detailed design. We have extensive experience on the R&D side as well, so supporting things like kit of parts and modular product development and performing value engineering activities. We can assist with temporary works, for example, propping, hoist and loading bay connections, things like that. We are experts in advanced structural analysis, specifically finite element analysis, or FEA, and we have capability for CAD/CAM modeling up to the manufacturing level, or LOD 400. We offer peer review and structural certification. We're both chartered professional structural engineers. We have the relevant PI insurance, national registration, and state-based registrations in Victoria, New South Wales, and Queensland. So over to you, Marco.
Thanks a lot, Jesse, and once again, thanks WoodSolutions for having us today. Before I start presenting, we appreciate that, and not everyone in the audience comes from a structural engineering background, so we keep our discussion high level and avoiding getting too technical. But let's get started. So bracing system typically, feature lateral force resisting system that provide structural stability into our buildings. And these kind of systems react to lateral forces such as wind and seismic. The placement and sizing of lateral force resisting system play a crucial role in ensuring stiffness, which is very important in order to prevent excessive lateral sway and twisting of your building, as well as providing the necessary strength for structural integrity. In addition to that, though, by properly designing bracing and connection in mass timber, we can enhance the design for manufacturing and assembly, which is the kind of DFMA approach that we know quite well. So making manufacturing and installation in that case as a very smooth and efficient process. But in order to achieve that point, it's crucial, in our opinion, to start since the beginning in thinking about the way you want not only design but also physically manufacture and erect your building. In this case, bracing system. Now we can step into the bracing typologies, each of which has its own pros and cons. It's very important because understanding these differences, is key for you in order to select properly the bracing system for a specific given project, making sure you can deploy, the most efficient solution for your project. In here, for instance, we have several bracing system applied to specific buildings. For instance, starting, from the left, there is the Bond in North Sydney, which uses a multi-story floor bracing system. Its primary advantages include, minimal facade impact, fewer elements, and number of connections that you have to deal with, typically ending up with cost efficiency. However, it faces some sort of, limitation in terms of stiffness and strength if compared with the other solution, and probably might pose some sort of challenges from a prefabrication point of view if it's needed. The middle one is the International House in Sydney, which is featured by a chevron bracing system, or as a well-known inverted V-shaped bracing, which offers, of course, high strength and stiffness in this case, but despite these benefits, it might raise some sort of concern in terms of complexity. So comparing to the previous one, given, the same building size, is essentially ending up with an additional number of elements you have to deal with, that we need to, manufacture, we need to provide connection for, etc., etc. Moving to the right one, there is the Marine Teaching Centre back in Canberra, which utilize an bracing system, which is known very well for its stiffness and strength. However, might raise some sort of, potential concerns, including aesthetic. Sometimes we have to deal with architectural, expectation or clients' need, and where actually they don't really want us to put bracing through glazing or facade. In addition to that, it might have some sort of issues, as I said before, in terms of manufacturing implication, which of course might impact the cost efficiency of your buildings. Another well-known system is the one using the wall and truss, or a kind of combination of variation of wall and truss, which features, for instance, the colonnade pathway in the International House Sydney. And this system excels in aesthetic, glorifying the use of timber and providing this double high, colonnade pathway, which is unique, in my opinion, for this kind of building. However, it faces issues with the durability and maintenance point of view. For instance, the way building is stuck on top of the colonnade, and where, might pose some sort of challenge in terms of transition node for transferring properly the load. It might request additional design, specs and time consuming for dedicated, transition steel node. That, of course, is going to impact cost efficiency of your building, of your project. Well, finally, we have an example. This is a next bracing system. The particularity of this one is the location where the bracing intersect, which requires specific attention and solution in order to make sure we can deal properly with this kind of detail. And the advantage by this system is about, the great level of stiffness you can achieve, and even the level of prefabrication and standardization that actually you can achieve. Okay, so in terms of connection design, we should probably first discuss about what kind of role do connection play in timber construction. Well, in my personal opinion, connection are where the truly, magic happens. They do much more than just holding pieces, element together, but it's the way actually we can transform individual pieces into a cohesive functional structure. So we can definitely say that, connection in bracing systems serve two main purposes. They assemble element into the design and shape we want to achieve, as well as it does provide the necessary stiffness and strength we need. Here is about the way we can discuss the importance by specific location and details in mass timber bracing. For instance, we have the middle point in the beam where diagonal intersects, as well as we have the this location in where essentially, diagonals approach the corner defined by columns and beams. And as I said, these locations are crucial, in terms of number of elements to connect, and also in terms of fixing, we need to deal with the way we need to process timber element in the right way, and everything are connecting together properly. Another one, of course, very crucial in our opinion, is at the ground level, where the intersection in between multiple material is going to play an important role. So in here we do have perhaps steel, timber, and concrete, connecting, interfacing together. So this is a kind of situation where a very holistic and synergy approach, talking with supplier plus builders and installer, is going to play an important aspect of your design process. Also, by looking at the top right image, it records me the importance of properly engaging the bracing system. In fact, in all cases, it's paramount to transfer diaphragm forces from the floor slab back to the bracing in a proper way. And for instance, depending on specific situations, we might need to design specific connection for slab to beam, slab to slab, and slab to bracing system. And in that case, sometimes additional steel elements such as strip, chores, and collectors might be necessary in order to enhance, the connection intents as well as the transition of loads. As typically, what might feature our bracing connection are a combination or series of flitch plates. In this slide, we can propose a variation of variety, let's say, of flitch plates. We have several configurations, such as the series of 3 flitch plates with the middle one thicker. There is another variation with 2 flitch plates and side welded steel plates, and also there is the double flitch plates configuration. This one might be the conventional one when experiencing high load to transfer, or in case we need, multiple shear planes to achieve a certain level of stiffness. And these flitch plates are usually pre-installed in factory using dowels or self-drilling dowels, which are then protected by timber plugs and covers. Moving on side, bolts are used to secure the connection, so just tightening everything together. And further timber covers and plugs are even installed to conceal the connection in order to provide the required fire resistance level. In addition to this, it's good to mention, in our opinion, a good product that can be a game changer for cost efficiency, especially in seismic prone areas. I'm thinking about, for instance, regions such as New Zealand, US, and even some part here in Europe, in which is the kind of product developed by Tectono. This innovative solution allows for designing and apply displacement-based design and capacity design approaches in a very resilient way, with minimal damage left in your building, making this product perhaps the ideal one for ensuring both, safety and cost efficiency in seismic regions. It was worth highlighting, in our opinion, this product. Moving into the design aspects, it's crucial to understand the importance of ensuring the specific or a specific behavior in timber connections. As I'm sure most of you know, timber doesn't really have post-elastic capacity, which can lead to potential brittle failure. In this scenario, especially in mass timber bracing, our goal is to ensure that any possible failure would occur on the connection side, which, if well designed, will predict the specific mode we want. So essentially, we can govern the way we want potentially the element to fail. In order to achieve this, there is a kind of best practice we can rely on. Typically, we rely on Johansen theory. This is a kind of theory that, very well known, and it provides us a series of load-bearing formulas that we can use in order to size and configure our connection geometry. And following this method, we can design our connection so that the overall group of fasteners features a kind of ductile mode of failure. We have discussed about the importance of avoiding brittle failure just right before. And in this slide, you can see what typically brittle failure might look like in mass timber. Even brittle failure can be calculated and addressed using best practice, approach and formulas. There are tons of R&D, done, recently in the past that actually you can rely on. Also, there is some sort of quote where you can rely on in order to pick up, the best approach for evaluating and capturing that kind of situation in your bracing system, or generally speaking, in any other connection you are designing. Now that we are in the position to calculate both fasteners group capacity and potential brittle failure capacity, what you need to make sure about is to ensure that the group of fasteners has less capacity than the first brittle failure that could occur in your configuration. Of course, this approach is always important, but it's even more important in seismic design, and where we apply capacity design principle to ensure that structure fail in location where energy can be properly dissipated. So we as engineer decide, which part of the which part of the building we want to fail, and in mass timber, typically we are referring to a specific connection location. And following this approach, all the location should be designed with a kind of overstrength factor to prevent any possible brittle failure. So making sure we can definitely rely on capacity design. We also briefly discussed earlier, about the importance of designing connections that allow our building to sway and twist within a specific performance level. And to capture this, we typically delve into FEA and properly model the bracing by implementing the stiffness. And in this scenario, it's crucial to consider the equivalent stiffness, which can be represented for us as a series of spring, actually, from timber, fastener groups, and sometimes steel plates. I say sometimes steel plates because if you see the image on the right, you might be dealing with a situation where, for instance, you have element with a quite long sticking out steel plate, which might need to be captured from a stiffness point of view. In order to address this kind of stiffness, normally we rely on a bunch of formula that you can find, for instance, in Eurocode 5, that actually provides sets of formula for different or several configurations you might be dealing with. And in addition to that, we can rely on a specific other formula that well known for understanding and define the steel plate stiffness. So now from an FEA perspective, there are various, ways and methods you can deploy. And we suggest keeping it, simple or as simple as you can. For instance, by calculating the equivalent stiffness of your connection, including any steel plates, in case it's needed, and then add these and, as kind of end releases to your timber element. Another aspect you might want to consider when you model, when you want to capture an overall, stiffness behavior of your building, is to consider the implication of the slip that might occur in between, for instance, bolts and steel plates. And actually, that kind of slip must be overcome, before a proper stiffness is engaged, of course. However, this might lead you, to fall into kind of nonlinear, consideration and analysis with its own set of pros and cons. So pay attention when you deploy such a system or such methodology. Now, from a fire point of view, when addressing fire aspects in timber bracing, it's essential to follow a kind of comprehensive fire strategies that incorporates multiple measures. Key elements of these strategies include, for instance, compartmentalization, the use of backup systems such as sprinklers, and specific methods related to bracing and connection, such as charring rate methods. In addition to that, proper cover, timber planks, and sealing are also crucial in order to protect and achieve, the right, fire resistance level you have to ensure in your design. Now, stepping into manufacturing and installation, it's also worth mentioning that if we aim to design and deploy a successful, bracing system along with, connection data aids it's crucial to get involved with the supply chain and builders and installers, as early as possible in the process. Early supply involvement is paramount from a manufacturing perspective in order to align, with suppliers, for instance, capabilities, limitations in terms of production, sourcing, the kind of degree of prefabrication or pre-installation you can achieve if it's needed, of course, and understanding, for instance, the documentation they would expect from you is another very important thing, because it might impact your scope of work. So there might be supplier that is, are totally happy for you to hand over to them with a, set of 2D drawings plus sketch, but there might be somebody else that actually want you to achieve an LOD 400 model, so they actually can go straight, and processing, the element. So this is very important because actually my impact, as I said, your scope of works. From an installation perspective, several factors play a crucial role too. This includes, for instance, logistics, on-site prefabrication if needed, tolerances, connection accessibility, lifting strategies, and sequencing, for instance. And the way you manage all these aspects, meaning, manufacturing, installation, is crucial because it might ensure, a proper and smooth, overall process going through manufacturing to installation, leading to the successful implementation of your bracing system. Well, we know there might be, much more to talk about on this kind of topic, but based on our personal experience, I'd like to share some nuances of, of connection implications on site. For instance, when comparing cast-in-place anchors versus post-fix anchors, cast anchors, of course, would allow you to transfer higher lateral load or higher forces, but of course, make installation trickier in dense location, like you can see here. You might end up with location full of, steel reinforcement, steel mesh, tendons, etc., etc. Even accessibility for connection can also pose challenges. For instance, when there are access limitations from outside the building, installing bolts might be risky and difficult. In such case, for instance, from a design perspective, you might want to deploy a welded nut prefix on the external side. But this kind of situation might even raise, tolerance issues. So it might be tricky when you slide bolt through multiple steel plates and, making you ensure you have to achieve, the thread or the welded nut from the side of the building. And finally, we believe that, for instance, the inverted V-shaped bracing is often better from an installation standpoint compared to a combination of single bracing systems. In fact, in this system, typically, if we require, a precise installation sequence to properly fit, the diagonal within the timber frame, which can complicate, in our opinion, and somehow the overall process from an installation point of view, of course. Well, so we just had a brief overview of some key aspects, you need to consider when designing connection in bracing systems. And if we should condense everything we just discussed in a couple of words, I would probably say holistic approach. This is what definitely will place you in the best position to deliver a sustainable and cost-efficient connection in bracing system. So very quickly, we talk about the importance of design in order to provide, enough level of stiffness and strength, possibly resilience, of course, the importance of the early supply involvement, as well as talking, with installers in order to de-risk as much as you can, adverse situation you might face on site. And also the multidisciplinary approach. We didn't really touch base, for instance, to other very important, topic in our opinion, which might be facade, and the way facade might impact or interact with bracing system. Most of the time, bracing are placed, all around or along the perimeter of your buildings, and you just need to make sure about facade aspects too. MEP, sometimes, for instance, bracing might fall into the footprint of your building, and they might need, services and kind of pipes going through So in that instance, you need to make sure what about implication might be from a design, manufacturing, and of course, installation point of view. Another one might be, of course, placing, bracing, in the core, shaft or stair shaft or lift shaft. So you just need to make sure, even in that case, any kind of interaction or issue you might be facing along the process. Last but not least, is also important, to have in place a good OEM strategy. This is also important, not only, of course, for mass timber, bracing system, but overall speaking, for any mass timber or probably for any kind of structures. So in this case, by dealing with the particularly OEM strategies, we can ensure the durability and keep, our system under control, et cetera, et cetera. So yeah, that was probably all from our side. So once again, thanks a lot for having us today. And back to you, Jesse. I don't know if you want to say something else before closing out.
Thanks, Marco. That was great. Yeah, just last comments. We've got our contact details there. So if you wanted to reach out and chat about all things mass timber, or if you've got any projects, reach out. Happy to, jump on a call or have a coffee.
Thank you, Jesse and Marco. Thank you very much for that presentation, Marco. That was a real cavalcade of information on a topic that I know can confuse and really cause a lot of stress for people when they are designing their mass timber buildings. We have a bunch of questions. You flew through that, so you have ample question time. So if you're listening and you have burning questions, please, this is your time. We're here for you. So put your questions in the chat box, upvote the questions that you like, and we'll have them answered today with two experts who are here today with us today. So I've got a few questions. One of them is, what's your personal favorite bracing system if you had to pick one, Marco?
Oh, well, there is no specific, preferred one. As I said, probably one of the things I would like to say since the beginning is just approach to a kind of holistic methodologies, because depending on what kind of project, or what kind of supplier you might be dealing with, depending on the kind of architectural expectation and client's needs, you might want the kind of elasticity, and you need to have the kind of knowledge for you to make sure you might be deploying the best possible systems. In terms of connection, well, I would say probably, the kind of flitch plate, is probably, the one we presented, and it's the more, it's the easiest one we can achieve, both from an installation point of view.
Could you put that out in the presentation for us, in case people aren't familiar with what that means?
So yeah, I was referring to, for instance, these kind of systems. Sorry, leave it like this. I'm referring to this kind of system. As you can see, is a series of flitch plates that essentially are inserted into the specific timber slot. And timber, is going to go through, a proper CNC manufacturing process, creating all the kind of recess, notch, holes you need, allowing for the specific tolerances. And then essentially they are pre-installed by using, a series of dowels, typically, and they are secured to timber, and they are then plugged. So everything, can be very, clear and polished. And the only thing left on site is essentially the way you need to put elements together. And most of the time, one of the trickiest part in this case is to allow, enough tolerances, both from a steel plate, so they can slide, together properly, and also when you slide bolts through. And of course, they might pose some sort of issues, because from a structural engineering point of view, we really like to be, as tight as possible, so that actually the bracing can be engaged properly, immediately. But from a manufacturing installation point of view, definitely we need some sort of tolerances. And this is exactly what I'm meaning. So, keeping the discussion ongoing, be open, holistic approach, talking with everyone involved is the only way you can deploy the best possible system.
And of course, with a connection like this, you end up with a fully bolted connection that can be quite quick on site, like that sketch you have in the top left-hand quadrant, only has what 3, 6, 9, 12 bolts on site. So that's obviously a massive benefit too, right?
Yeah, that's right.
What's the best approach to specify a bracing system? Because we see a lot of systems that might be prescribed or set from an architectural standpoint without really getting into, or without being driven by like a structural need. There's at least one mass timber building in Australia that's been built that doesn't actually engage its bracing system. It actually uses the core entirely for its structural stability, and the bracing system is simply there for show. It's just pinned in. What's your opinion on that? And if someone is an architect trying to figure out what the right move is, because of course these bracing and truss systems have a humongous architectural impact on your building, so you have to kind of commit something forward at a concept stage. What advice would you give to someone who is not a structural engineer but still has to sort of make those sorts of decisions?
Well, bringing my personal opinion to this kind of question, a good question, by the way. Well, in my opinion, it's just everything about a kind of equation we need to balance. You are I'm a structural engineer, and of course, the easiest thing to do would be just dealing with structural things, try to understand the behavior of the building, exactly the position I need the brace, and in order to maintain everything within the expected performance. But we know it's a kind of dialogue we need to have with, all the other, actors involved. So architectural intent is, a very important thing. The client's expectation is another important thing. As I said before, manufacturing, installation, amplification is another thing we need to consider. So if you think it's a very wide, and complicated, equation that we need to balance properly. There are many facets, in my opinion. So from an aesthetic point of view, I would say, I would use, timber bracing every single time we need. So talking with them, we need to understand, is acceptable to have bracing, through your glazing facade, etc., etc. If we need anyway the bracing to be placed in that location because we need to, stop or kept under control any kind of twisting, behavior. We can try to work, together in a way that we can minimize the impact of bracing, such as the image we showed before about the bond in use, in North Sydney. That building, in my opinion, is expressed a very good level of architectural intent. Still probably, I wasn't really involved in that project, of course, but still probably provide, what it was meant for, so providing lateral stability. So it's a kind of combination, in my opinion. And I'm not really a fan to bracing put that just from an aesthetic point of view, because, even if it's going to be just from an aesthetic point of view, bracing system is a very complicated system to deploy from a manufacturing installation point of view. So what's the purpose? It's going to be a super premium luxury building where you want to express, and glorify the use of mass timber. Fine, but you probably need to put on table, an extra budget, because placing bracing system is a kind of very cost, and time-consuming aspect you need to consider. So I would typically say using bracing system every single time you need, and balance, properly, talking holistically with all the actors.
So it sounds like sorry, you please proceed.
Thanks. Just to add, bringing in the engineers early gives an opportunity to kind of avoid locking in a potentially suboptimal solution. Because if design is all about placement and sizing of things. So if you kind of position the bracing where it has to work a lot harder than it would in another location, it can kind of add to the cost and, add to the connection effort and all this sort of thing. So I would say, it's just a collaborative exercise.
Yeah. So if someone's putting forward concept, they don't have much time, they can't, like, the building is not that defined yet. It sounds like many parts of design, if you step outside your area of expertise, you can sort of get into trouble by baking in sort of as you say, suboptimal directions, that a phone call is probably the best option to just talk about it so you can achieve your architectural intent while leaving room for an appropriate structural system, not a superfluous one.
Right.
Thank you very much for that. Another question here: are ring bolt connections suitable for mass timber systems? This is from Robert. I presume Robert means ring bolts as in like shear plates and whatnot for those shear connectors as opposed to the steel flitch plates. Have you had any experience attempting that before?
My experience is that they're not used widely anymore. I mean, I could be wrong. Maybe people out there are using them, but I think if I've got the system right, it's like the split ring shear connectors that kind of it's a ring of steel that kind of gets sandwiched between the connection and then bolted, and the steel provides a bit of grip, if you like, or interlocking. To my knowledge, they're not widely used in systems today. I haven't seen them used, that is. I don't know, Marco, if you've got anything to add.
Well, probably the only thing, I'm not really familiar with that kind of system, to be honest, specifically in bracing system. One of the things we want to make sure about, of course, is to achieve enough stiffness. And in order to achieve that kind of aspects, we just need to be as tight as possible. So downwards is fine, and keeping, the tolerances at the minimum. So unless we might be in the position to have a kind of system like that actually can provide, the right level of stiffness without any kind of slip in between elements to be won, before the stiffness to be engaged, is probably something that, I would avoid.
Right. I've got two similar questions here. One is there an aesthetic reason that you hired the connection to the timber, or is it just a fire protection? And the second one is, can you expand on the importance of weather protection and the impact of long-term exposure on critical connections? So these are kind of related. Yeah, have you got any thoughts around the aesthetics and then the durability side?
Yeah, well, sorry, I'm just reading through the question. So well, from a weather protection, it's always, a crucial aspect we need to govern properly. And one of the things, in my opinion, is start much earlier than just, installing piece of elements and put piece of elements together. Is a kind of strategies. So it's like making sure, the way you also to risk any kind of, watering impact during the installation phase. So is to have a proper installation sequence in place, not only for the bracing system, but for the overall building. Try to keep, as minimal, at the minimal, the installation sequence. So moving one floor to the other quite quickly. So they're actually one of the good advantages by having mass timber is that essentially, as you move on floor by floor, you can stop wrapping the building, so protect the timber as much as you can. So you have to think that, mass timber is a natural material. They're actually, of course, get impacted by weather conditions. So it's more, even in that case, I'm just stressing about the holistic approach. It's not the way there is small aspect you can deploy, but it's a kind of overall picture you need to consider when dealing with system like bracing in this case. And what was the other one? Sorry.
Well, and so just on that durability side, like the goal of those efforts is to avoid consequences like premature rusting, expansion of the timber. Like, how does this go wrong?
Jesse, would you like to say something?
Yeah, sure. So, generally speaking, on a construction site, you've got the risk of things getting wet. It's almost bound to happen. So how does that go wrong? Generally, it's just cosmetic issues. Unless it's exposed for a substantial amount of time, like if it's weeks or maybe a few months, it's probably going to just cause some cosmetic headaches. So you might start to see some discoloration of the timber, that sort of graying that you get with exposure to UV and rain. That obviously when timber gets wet, there's a bit of swelling and then subsequent drying phase shrinkage. So that shrink swell cycle can cause some shallow cracking. So you can get that sort of effect, especially with engineered wood products like a glue lam or LVL, which has these bond layers. You can get some splitting of the bond layers depending on the adhesive, I guess. But also you've got just practical considerations, like generally there's going to be, for example, a prop, which the face of the prop might be screwed or bolted to the face of a column or something like that. So that is going to lead to, you know, a little spot, a patch, if you like, when the prop is removed, you're going to have different levels of discoloration from that weather exposure. So there are practicalities like that to think through. It's usually not the end of the world, but I would say plan for a little rectification at the end once everything's enclosed by the facade. And I guess
awesome.
while I'm chatting, I can try and address the fire question as well. So
Yeah.
I think it was about whether the plugs and dowels are more aesthetic or for fire. I'd say it's a bit of both, predominantly fire. So where you've got a steel connection in a fire or exposed to a fire event, the steel being a better thermal conductor than the timber, the steel heats up very quickly. And basically unprotected steel, what will happen is, I think once it reaches about 120 degrees, so not even that hot, it'll start to soften the timber or the kind of the natural glue that holds the wood fibers together. That'll start to soften, so you'll get some deterioration of the joint there. So it's kind of the plugs are introduced to prevent the steel from heating up and then compromising the integrity of the connection. But they also look pretty good.
Yeah, there's definitely a case of lots of things doing more than one function simultaneously. I've got a question around when and when not to use. So what sort of mass timber building does not need a bracing system?
Well, it's just completely different approach in terms of the system you're going to deploy. So you have to consider that most of the time bracing the system is probably, even if it's quite, you know, cost impacting your building, is essentially the easiest thing to do in order to keep all the other connection in between element, you know, very easy. So typically when we put a timber element together, is essentially the way we can minimize the connection. So essentially, from a structural engineering point of view, they are such pins, you know, put together. So keeping minimal, you know, the steel plate, number of fasteners, etc., etc. So that will lead you to, you know, the necessity to have a proper bracing system in place, in where, you know, through your bracing system, you can just essentially makes your building withstanding, you know, through lateral forces. Another system might be, of course, to have more rigid connection in between the elements, such as very rigid connections, or even in this case, we can deploy a series of fridge plates or bolts, etc., etc. But this would, you know, increase a lot, actually, the implication in terms of manufacturing installation, and actually the way you need to achieve enough level of stiffness, it might pose a lot of challenges, you know, into your connection. And the mass timber is very crucial, you know, and play a crucial role the way you are defining and addressing the stiffness. So from an FEA point of view, it's not a straightforward things for every single rigid connection to idealize that connection as a very rigid or super rigid or infinitely rigid. So you just need to make some sort of assumption in terms of the way you can specify within your model the stiffness. So it's something that, unless, for instance, for specific structure, like such as might be, I'm thinking about industrial shed, where you have a kind of portal frame, so in where, you know, the junction in between element can be quite rigid, but they are very located. For a multi-story mass timber building where there is hundreds, if not thousands and thousands of connection, you know, ending up with rigid is not cost efficient.
If I have a building that is, say, like a residential tower, if I'm at like 1 story high, I might not need a bracing system. At 5 stories high, I might. How do you sort of draw that distinction in like a residential tower versus like an office tower? Where does that, in your gut feel, generally come into play?
Generally
Yes,
speaking, I would say, I mean, it depends on the project requirements. So you can have, there's no hard and fast rule. You can, I think what you're getting at is kind of at what point do you start to need to rely on a hybrid system, like perhaps either steel bracing or a shear wall or even cast in place concrete cores, for example. So generally speaking, you're in the realm of taller structures, kind of maybe 12 to 15 stories and up. You'd be starting to think about needing the stiffness of a concrete core or set of concrete shear walls. Kind of the low to mid-rise, 8 to 12 stories, I think is a sweet spot for the types of bracing we've kind of had on show today. Like I'd say some of the projects we've had on the screen probably sit around 6 to 9 stories. So that's the, I guess, the sweet spot. You could push it a little bit higher. And then, but that's not to say, for example, we've seen other projects which might only sit at 4 stories, but they've still got a concrete core, for example.
So the requirements definitely do lessen, but you can still have a scenario where they are required on a 1-story building if you don't have other methods to restrain the building.
Absolutely.
yeah, definitely.
With the bolted connections, how are those bolts and those nuts and washer and tightening arrangements designed so that they can't loosen over time?
Yeah, well,
Or is
that's a
it
great
what
question.
kind of consideration is around that?
Well, typically there is a kind of specification you can rely to, there are, you can find within standards or codes, etc. But as I said before, the thing you want to achieve is the stiffness, and you want to make sure your, building from from a lateral system point of view can get engaged, immediately. So you need to minimize, the friction potentially in between the element. You have to avoid, to have bigger roll, etc. So the way you tie everything together typically is also specified within specific coding where you can enhance, the knife, the ride, and enough, torque force you have to apply. So tighten everything together up to a specific level of, requested, torque. I don't know how I can say in English, to be honest.
That's right.
Kind of, I like a kind of range of torque you need to apply in order to make sure that actually there is nothing in terms of slipping, and friction, to be won or cooling in between the steel plates. And one other thing that in my opinion is important, I was reading the question in here, is that, as I said, we need to minimize, the clearance in between hole and steel plates. And of course, slotted holes, I know it would be ideal from an installation point of view because it would, increase, dramatically the tolerances on site. But it's definitely something, that we have to depart from making sure the bracing, is engaged properly. And unless it's not going to be, like we said before, it's some sort of aesthetic, element that actually the building is relied to something else. So in that case, you can have some sort of, let's say, fake bracing. So in order to, ease the installation, definitely you might have a bigger roll or slotted roll, etc.
Great answer. I think to close, I've got one last question here. So you've spoken a lot about research and the kinds of like engineering strategies that we use to model what's going on in the real world, and we're always getting closer to understanding the brittle failure of timber and how different connection stiffnesses interact and multiply and stack onto each other. How do you see this framework of study and application developing from a building code standpoint? Do you see this being integrated in anything anytime soon? Are you aware of like a specific nation or body that's doing a really good job of it? What's your opinion on the sort of code landscape of bracing systems?
Yeah, So, don't know, Jesse, from my personal opinion, I've been, of course, in this kind of realm for more than 15 years now. So I've been following a lot kind of R&D stuff, PhD done. And what I can finally, and I'm very, happy to say is that fortunately we are gonna have soon, at least, coming from, Europe, we're gonna have soon the new, release and it's called the new generation of Eurocode. So actually, if you compare the current Eurocode file is a kind of 50, 70 pages, the new kind of Eurocode is around 300 or 400 pages. So, which it gives you an idea, how much, comprehensive is gonna be that kind of code that actually can be used like a framework, and it's gonna consider, it's gonna, include all the kind of R&D stuff, not only in terms of connection, which is definitely a great stuff, but also in terms of vibration, the use of multiple material together. So TCC, for instance, timber concrete composite, and actually, hybrid panel or wherever other, CLT, of course, is gonna be, embraced properly. And of course, there are already, many of codes, for instance, in US, they're addressing very well, the timber issues. So I really like to say people, holistic approach, open your mind, try to find, the best possible information you can get. There is the way you can download the draft version of the EC5, and actually you can see, how brilliant it's gonna be. And this is good because it's good for a mass timber point of view. It means that actually timber is becoming even more streamlined, which is good. It's a great material we have to use to deploy our system from now in the future. So it's important to have a quite robust set of codes we can rely on. And I'm sure Australian Standard will be doing something very soon for all of us.
Yeah, just to add to that, I mean, in the Australian context, my information is probably a little out of date. This is kind of something from a while back, but we had Johansson's yield theory on the slides before, so they were kind of the Dow connected, the ductile and brittle failure mechanisms for the Dow type connectors. I had heard that AS 1720, the timber structures code, was moving from the current approach for connection capacity towards Johansson's yield theory. I don't know where that process is up to, or if that's still the case. So don't quote me on it, but I wouldn't be surprised if we see that in the Australian codes sometime in the future.
It's fantastic to hear about the European code expanding to such a deep level. That expansion is going to clarify a lot for a lot of people, and as you say, just make it answer a lot of questions and remove doubt for people. Much like this session today, I hope it's done for everyone here. So please, thank you, everyone. I'm sorry. I think everyone will agree with me that that was a very, very informative session. Thank you very much for joining us. We're very, very lucky to have you for this last hour and to pick your brain on this area of expertise that you guys have been working on for a long time. We've got decades of experience between you. So thank you so much for your time. And again, if anyone has any questions, if you have a phone call that you want to make to find out if your concept building needs a certain kind of mass timber frame, I can tell you that these guys are really, really great to talk to, and we'll definitely listen to your listen to your questions. So thank you so much for being here. It was an absolute pleasure to chat with you today.
Thanks, Colin.
Before we sign off, thank you. Before we sign off, I'll just end the webinar by sharing a little bit about the Australian Timber Design Awards, which are open this year. Last year was a fantastic success. The Sydney Opera House's concert hall renewal took out the award with its incredible interior fit out, and we can't wait to see what amazing projects take out the competition this year. And the next installment of the WoodSolutions webinar series is on Tuesday, the 2nd of July at 11 a.m, the regular time. It is the AMRF First Building case study, designing for country and disassembly, which will be a great webinar. We don't get too many projects in Australia that really do have a strong focus on the design for disassembly. So don't miss that one, lock it in, and I'll see you in the next one. So Thank you so much for your time. Have a great evening. Ciao, ciao.